Hello, Zero the whole world. Again, we're still dealing with chapter 7, single dimensional arrays, and we are specifically working on 7.20, as you can see. And if you haven't yet read this, if you did not watch my previous solution, you can pause the video, read the problem on hand. Okay. In the meantime, I'll get back to my IDE with doing 7.20. Okay, as I mentioned before, this right here will apply a concept that we haven't yet covered, which is the double class. The double class is nothing else but a class version, a data type, and a class data type version of, that is super noisy, of the double primitive data type. Okay. Blah 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 blah. Okay, what else? Again, we're gonna declare an array the same way we did on our previous solution. I can take any 10 random numbers. That's 1, 2, 3, 4, 5. What the F is going on? Let me just go 0.0, 0.9. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Last but not least 10. Okay. Gosh. So that everyone can see what's going on, let's put these numbers. Let's align them just like that. Okay. Again, I'm gonna invoke the sort method, which I haven't yet created. I'll then go for each item in array. I'll display it. System.out.print. There is not correctly spelled. Okay. Public static void sort. The reason why we went for this approach is because I want to demonstrate the usefulness of the compared to method defined in the defined in the comparable interface. Again, I know I might be creating confusion there, but you see, classes that implements the comparable interface have this method called the compared to method. And again, you can do a little bit of research of your own on what the heck is a comparable interface. Okay. Again, the approach will be more or less like what we had before. Okay, it's just that we'll be playing around with the compared to method. If this is less than 2, we return what? Or we stop our method. Otherwise, double max int max index. This is the exact code. Or perhaps not exact, but it is similar to what we had before. Array dot length -1, I is greater than 0, I minus minus. Now max is equals to array at I. The truth of the matter is, the only difference will be on the way we're comparing our current element with our current max. Okay, and you will see in a moment how we're gonna go about doing it like that, doing things using the compared to method. Int j is equals to max index -1 is j greater than or equals to 0, j minus minus. Now we're going if array at j compared to max is greater than 0. If this is the case, okay, so here's the deal here. You see the compared to method, it either returns in fact it returns an integer. If the integer is positive, which means the objects, because right now we're talking objects and classes since we're using this right here. Double is a class and max is nothing else but an object. Okay, and this, you see this array here is an array of objects. Okay, so array j is an object, so we're calling from that object, we're calling the compared to method, and we're comparing it with this object here called max. You see, if the object from which the compared to is invoked from, if it happens to be less than the other objects, then the method will return a negative number. If they are equal, it will return 0. If it is greater, then it will return 1. I mean a positive number. Okay, so in this case we're saying if the returned number when invoking the compared to method from array at j, this object right here, if the returned number is positive, which means that this object right here is greater than max. Okay, I mean the idea is still the same. It's on the difference is only in the syntax. Okay, so I'll simply go max is equals to array at j. I'm updating my max, and max index is equals to j. Okay, and once we're done with that, this is where we get to do the swap. Okay, now we want to compare max with what with array I. And again, if this returns something greater than 0, immediately we know that our current max is greater than array I. Okay, so temp is nothing else but array at I. Folks, I must tell you, see, the next exercise I'll be jumping on is one of those exercises that I shouldn't be doing. Why? I mean, simply because the point here is you've got to learn the basics of arrays. But when it comes to complex problems, it is your task. There is absolutely nothing much I can do. It is your task to go through the pain of not understanding things until you figure them out on your own. Okay? But you know what? I am going to consider giving a solution. Okay? But if you decide to watch that solution, I dare you to please give it a try yourself. In case you get stuck, then you jump onto the solution, you watch it out, okay? And if you don't, of course, there's no reason for you to watch my solution, not unless you want to do a little bit of comparison, okay? Again, we're done here, you folks. Again, feel free to let me know in case I messed up somewhere somehow, or you find my code inefficient. Okay, as you can see, we have a nope. This isn't. I wasn't running the correct file. Again, the same stupidest mistake I did. Last time, what could be the problem? Really? Is J greater than or equals to 0? Damn. Not I. Boom. Seems like we're good, everyone. As you can see, we've got a sorted array. That's gonna be it for this tutorial, you guys. See you on the next one, which is exercise 7.21. You see, it has 3 asterisks. Again, I shouldn't be tackling this exercise. You guys, please make sure you do it yourself. But I'm gonna do it anyways, okay? But make sure you do it yourself, you guys. That way you'll go through the pain of not understanding things, okay? Yeah, that should be it for this tutorial, you guys. I'll see you on the next solution.